Thank you for coming to the talk. So it's really nice setup. It's my first time here at ContainerDays, and I'm delighted to be here. So yeah, my name is Yostos, and I work for Tigera. Tigera is an inventor and maintainer of Project Calico. So today's talk entitled to using open source software to secure cloud native applications. So it's going to be a quick overview and introduction session to Kubernetes security. Our agenda today is not too long, it's quite short. So we'll start with talking about Project Calico, what is Project Calico. Then we will have a quick discussion about Kubernetes network model, then the CNI key consideration for a secure environment. Then the last thing will be talking about network policy and a very quick demo. So what is Project Calico? Project Calico is a kind of, it's an open source networking and security solution for containers, virtual machines, and workload host-based workloads. So it has been built to be a pluggable solution where it can run on any data plane. So at the moment, we support APPF, we support Windows data planes in addition to the standard IP table, IP sets. And recently we introduced VPP, and it's in tech preview at the moment. So the Calico network design is very simple. It allows you to run layer 3 network without any encapsulation. In some use cases where you can't enable layer 3 without encapsulation, you may need to have overlay network, and in this case we support IP and IP overlay or VXLAN. Because of the simplicity of the solution, the solution has been tested. Project Calico has been tested to the scale of the limit of Kubernetes, and this is because it uses the well-known technology, the BGP. It relies on BGP, so that made it to scale to quite fast. Just to let you know, we have over 6,000 members on our Slack channel. We have over 150 contributors, over 1 million nodes powered by Calico every day. There are a lot of social that you can connect with us, and we are available today in both C10. The one more number we are very proud of, that we have over 1 billion downloads of our per host agent from Docker Hub, which is immensely proud of. So that being said, let's deep in our talk today, the containers network model. So Kubernetes defines networking, but it doesn't implement it. It relies on another technologies to implement the networking model. But first of all, let's look at what the network model defines, that Kubernetes define here. So let's say that you have containers running on pods, running in your cluster, and for example, you have 2 containers running on the same pod. For example, in this example, it's pod A. We have 2 containers in this pod. So the first rule that every pod has one IP, and containers inside the pod will be sharing this IP. So this is the first rule that mandates how the networking works with Kubernetes. The next one, that it's very simple, flat-throated layer 3 network. And that means any pod can reach out to any pod in the same cluster without network address translation, without NATing. And that can be shown in this diagram with these red icons. You can understand that there's no NATing happening in this design. So there are many other rules here, but these are the main 2 rules that Kubernetes mandate the network model. So it's up to a chain of the CNIs to decide how the network is implemented, and Kubernetes actually doesn't care about how this network is implemented, as long as it just follow the rules that it put in place from the beginning. So CNI might implement lots of features that you care about from security perspective as well. It might implement encryption on the wire. It might implement Kubernetes network policy or more advanced extended functionality that fill the gap between the native security policy and something like Tigera or Calico security policy. It implements as well encapsulation for other scalability solution. But before we move on, let's talk about how and what the challenges actually is to choose the CNI. So when getting started with Kubernetes, CNI sounds difficult, they sound complicated, so people will often think that they want to kind of the minimal functional case to get started with. As a result, people often choose the simplest CNI that they can have in their environment, and they have the idea of retrofitting the security. Nowadays, everyone who worked with in security before, they know that the idea of retrofitting security, even with the traditional solution, with the traditional application, is not something straightforward. You can't rely on that. And changing the CNI in your environment after implementing is very hard, and it's much better to do it from the beginning, from day one. So likely the barrier to start with the most widely adopted feature, which Kubernetes CNI, are very low nowadays. It's actually quite easy to get started with CNI like Calico that offers a great deal of most functionality than the basic one. And you will find that in our documentation that the way to implement CNI like Calico is very straightforward. But what also you might care about when you choose a Kubernetes CNI, specifically with regards to the security environment, there are other considerations to be considered here. So the first one is that you have a trusted network policy implementation. I haven't really spoken about network policy, but I'll talk more in a moment about it. But it's the network filtering technology that Kubernetes mandates that the CNI can choose to implement. And I'm saying choose to implement because it's very important to understand that not all the CNIs implement a network policy. So Kubernetes has this concept of network policy, but not all CNIs implement it. Then you might want a kind of advanced functionality with extent that fill the gap, which are missing from the network policy. That's what we call security policy from our Calico security policies, something like global policies or fully qualified domain named, or creating policy based on fully qualified domain name, or whatever feature that fill the gaps. The CNI might implement encryption to protect data in flight between pods and nodes, and this is something you may consider if you work in a regulated environment or a regulated industry. And you're also going to want the CNI that has an active community to ensure that your issues will be resolved quickly. You have an active community to learn from and to share learning from and so on. So I think Calico did a great job to meet these expectations, but there's a great list of things to talk about it or to compare when it comes to choosing the right CNI. So that being said, let's talk a bit about the network policy. So I have mentioned network policy a couple of times. So what it is exactly? We mentioned that Kubernetes network is very flat, simple network, but the flat network doesn't implement any kind of isolation. There's no isolation between the workloads running there. And Kubernetes has the concept or that concept of network policy and relies on the CNI to take those rules to translate them into network environment for the Kubernetes cluster. And just choose on the way and the most appropriate way the CNI deems fit. These policies gets deployed on the nodes, spread throughout the whole cluster, which is great because it means that things will scale very fast. And again, isolation here is not defined by the structure of the network, it's defined by the network policy itself that's implemented by the CNI. So if you look at an example for any network policy, this manifest file, you can recognize that this using the API version, which is networking.kubernetes.io, and the kind is network policy. You see that it matched some pods here based on arbitrary label like color, and it has some target. It matched some target pods with label as well. But when we look to Calico network policy, you can identify that there are two different types of this policy. You can implement a network policy. You can get it from the kind and the global network policy, and the different that. The global network policy is something you can run it on the whole cluster. It's not related to any namespace. And you can see that in the network policy, under the metadata, we define that namespace equal production. But for the global network policy, we don't define this option because it's run on anything. And usually in the security world, you can use a combination of these two types of policy to implement a higher level of security, to introduce zero trust. And we have a use case to use this combination of the different policies. We will talk about it soon. Okay, so you can consider that Kubernetes network policy offer these features on the left side or the left column, and Calico network policy adds on a load of other features on the right side. So while the Kubernetes, the native Kubernetes network policy provide ingress-egress role, port selection, namespace selection, port list, IP block exception, traffic filtering based TCP or UDP. Calico introduced the global scope, the deny and log actions, the policy ordering, and feature match using service account instead of labels, and the layer 7 policy. I could drill into each of these, but given the time scale, I'm going just to focus on how important the namespace and the global namespace and denies are. So we have all heard about the shift-left security, the idea of allowing your security team to take the responsibility for the higher level security, and just allowing your project team to manage their own security alongside their own project, and just give. And that technique gives the organization a lot of benefits. So as I mentioned, using combination of Calico global policy and Kubernetes or Calico network policy, we can see in this diagram a nice use case to just where we allow the security team to manage the global network policy, and just the project team or the dev team to mandate and manage individually in each project namespace. So you can see here in this diagram, you see that the security team are, for example, allowing the metrics, using the global network policy, they're allowing the metrics collection on the whole cluster, they're allowing the DNS traffic over specific port between the different workloads, and the dev team just responsible on their own application in their own namespace. So that's all I have from the presentation. I will go through a quick demo to see how can we use the network policies. So in this demo, or for this lab, we deployed a 3-tier application called Yet Another Online Bank. The application consists of 3 microservices, where the customer is the UI, web UI, and the summary is the business logic, and the database is present the data store for this bank. So let me just switch to my, I think I can just increase the font a bit. Okay, so this is much better. So I will, okay. I have a 3-node cluster here, and if you see that my implementation, you see that I have the Yet Another Online Bank implementation there. I have the Calico deployed, the Calico CNI deployed, and the default kube system things. So now to check that I can browse to my service, I will just curl that my application. So just I'm sure that I'm able to reach out to my application. I'm getting this message, welcome to the bank application. And now I need to think about what if the customer board, which is the front end of this application, has been compromised, has been hacked. And given that this is a flat network, there's no isolation by default. And in case, let's say you are using a CNI that doesn't implement a kind of network policies, if this board, the user interface board, has been hacked, the user should be able to reach out, or the hacker will be able to reach out to my database and exfiltrate this data. So just to simulate that, I will exit the customer board, and I will try to grab some data from the database and see how it will work. So it's simply because there's no isolation between the different tiers in the application. I'm able to just exfiltrate all this data from my database. So what I need to do here, I just need to implement a kind of a zero trust approach, which is building shield around each service in my application to just allow only the traffic that I can trust to this application. So in our case, we have the front end, but the communication to the database should be only coming from the business logic, from the summary pod. To do that, I will implement my first network policy, and I will show you how it looks like. Let's exit here. Okay, so at the moment I'm just using a native network policy. You can just recognize it from the API version. It's networking Kubernetes. It's not Project Calico API. So it's called the database policy. And in this policy, I'm just allowing the traffic coming from the summary to the database. And this policy will block any other traffic implicitly. We are not blocking the traffic explicitly from the UI to the database, but we are just allowing the traffic from the summary to the database, and that implicitly will block any other traffic. So if I create this policy and Then I go to test, do the same thing, just try to what the hacker tried to do, which is try to get information from the database using the front end. You see that I exec the front end and or the customer, and I'm not able to get any data from the database. But the thing we are doing here now that allows us just to control a specific pod or a specific service, but in most of the cases, you need to have in place some other rules to, for example, default deny all the traffic. And this is the idea behind Zero Trust, just allow the trusted pods. And for that, that's where we can use the global policy, the Calico Global Network Policy. So in this example, I'm allowing just deny all the traffic, all the ingress traffic, all the egress traffic using the global network policy. And the difference between creating that with the native network policy or using, like here in the API version, Project Calico, that here I'm not specifying an enemy space. It's on the whole cluster. So it's kind of setting rail guards in your cluster. So now whatever the application the dev team will deploy, at least you have a minimum level of security. So I will do that. And after that, I will just try to maybe like reach out to external resource, something like Google here. Oh, I need to just exit. I was inside my pod, so I need to go out and apply the policy. And it's applied. So now if you try to reach out to external resource, and this is one of the things, like you want to prevent at least the north-south communication. So we are not able to reach to something like Google. One other use case that you may use the global network policy to allow specific protocols, like the platform team may ask that the DNS traffic should be allowed in my cluster, regardless of the namespace. So by doing that, I can again use network Calico global policy. It's not copied correctly. Just missed one line. Yeah, and here just I'm allowing the DNS traffic over the UDP, any communication going to the kube DNS, and denying at the same time any other ingress egress traffic, and using the namespace selector to exclude denying the ingress and egress traffic to something like kube system or Calico API service, where I need the traffic to be allowed there. So by allowing the DNS, if I try to reach to something like Google again, I should be able to reach out because that was the DNS traffic that is denied. So now I'm able to just resolve the name. I'm not able to reach, but I'm not able to resolve the DNS. And the last thing I will do today. So now we used Calico to enforce the global policies, what the security team will require, what the platform team will require, which is just traffic to be allowed denied globally on the cluster level, but still inside each namespace, you need to set your own rules to allow the traffic between or deny the traffic between the different services. So for that, I will just deploy some policies. Yeah, because in this case, I think of yet just want to show you that I'll do curl. I should not, I'm not behaving, what happened now that I block the traffic even to my web UI because I set in place the default deny policy rule. So you need to have some definition to allow, for example, port 80 coming to my web UI, my summary is communicating with my database, my web UI is communicating the business logic. So that being said, I need just to have this policy that defines how the different service will be talking together. So I do kubectl get network policy. Yeah, I just need to define my namespace. And you see that I have created a policy to allow the customer policy communicate with the summary and the database communicating with the summary and what the summary does exactly. So that was everything on my demo today. Let me just go back to my slides. What I showed you, it was part of our, we have many training that if you want to go through or if you want to start with learning about Calico and the different policies, we have some certification. This demo is part of the level 1 Calico operator training that we have. It's all free certification, so anyone can just go and make use of it. And we have a dedicated track for AWS, another one for eBPF if you are interested in advanced eBPF configuration in your cluster, and we have another one in Azure. All these certifications with the labs are for free, so just make use of it. And that's it. Thank you. I hope that has been interesting to you, and yeah, happy to hear if there's any questions.
Thank you so much.
Thank you.
I think I saw some questions. We can display them upwards, and we can see them also here.
Okay.
We wait for them. There they are. Okay, so in case you haven't, take out your phone and vote for the questions you think are most interesting. But we have one that has already 5 votes. Is there a way to show the final merged global network policy?
Okay, so we have Calico open source, and we have the enterprise version of Calico, which is Calico Enterprise and Calico Cloud, the SaaS offering. So in the Calico Enterprise, we provide a policy board where you see the different policies, how it works together. We build something called tier, and even this tier you can tie it using our back to different teams. So you can tie the tier security with the security team or the platform with the platform team, and you see visualization of how this policy and how the traffic get evaluated till the point it reaches it's allowed or denied. So it's available in our enterprise version.
Okay, there are more questions.
So, yeah, what's the relation between Tigera and Calico? Tigera is the inventor and maintainer of Project Calico, and yeah, so we support, we invent, and we keep all the releases, all the enhancement we do is we do with Tigera. Under Tigera, it's the mother company. Yeah.
Mm-hmm. What else do we have? Can you apply the policy with kubectl?
Yeah. If you're talking about the Calico policy, you may use Calico Cuttle, but there's another way to use kubectl, but we recommend if it's just open source environment, you must have the CalicoCuttle installed in your cluster and updated to deploy the Calico policies. Container firewall, how it is implemented. Okay, so this is a big topic. Okay, so look, so just in 2 minutes, like the problem that one of the challenges with container that IPs are ephemeral and containers are very dynamic. So if you batch your container, it gets with a new IP. So by doing this, you can't control the traffic with your existing firewall, your network firewall, because firewall require an IP identifier. So in Kubernetes, this is impossible. But with Calico, we do few things. We do something called egress gateway, and the egress gateway helps you to assign an IP, a real IP to your pod, or you can assign IP to the whole namespace. So instead of using external firewall to allow hold the traffic to the cluster, you can just allow to one namespace or one pod, as just depend on how granular you want to go in your control. This is one of the mechanism. We have different mechanisms like integration with existing firewalls like FortiGate or Palo Alto, a dedicated integration to control the traffic coming to your cluster and even between the different workload inside the cluster.
Okay. I think that's it with questions.
Yeah. So feel free if you have any further question, just come to our post at C10 and we can have a further discussion around this.
Perfect. We also have a card game for you.
Okay.
And enjoy your games at the Harbor Pub.
Thank you.
Thank you so much, Joseph.
Thank you so much.